Hi, this video is on projectile motion. This is a problem we did in class. It's number 9. This formula is in meters. That's why the negative 4.9, that is the formula you follow when it's in meters. For gravity, negative 4.9 is the coefficient for gravity. All right, so this problem says a bolt falls off an airplane at an altitude of 500 meters. How long will it take the bolt to reach the ground? All right, so because it drops, you need to know that velocity, or initial velocity, is 0. Anytime you drop something, or it just falls, your initial velocity is 0. The initial height, that's h naught, initial height of this problem is 500 because it's falling off an airplane that's altitude is 500. So, because initial velocity is 0, this part of the problem goes away or becomes 0. So I just solved this problem by taking square roots. I subtract 500 from both sides. I divide by negative 4.9. When I do that, I get around 102. And then I take the square root of that, and I get 10.1. So the question said, how long will it take the bolt to reach the ground? And that would be 10.1 seconds. All right. Great. Next problem. This is problem number 10. It says a ball is thrown upward at a speed of 30 meters per second from an altitude of 20 meters. What is the maximum height of the ball? All right, it's meters again, so you're still using the same equation that has to do with meters with your gravity at negative 4.9. Here's the deal. When you throw something up, this ball was thrown upward, our velocity will be positive 30. You throw it up, it's going to be positive. If you throw it down, it will be negative. Velocity has that direction component you have to add to it. So I put the 30 right here. The ball is thrown up from already an initial height of 20. So maybe they're standing on a building or something, 20 feet, or 20 meter building. All right, so there's my equation. You got to remember that this height is height after time takes place. So this is the equation, and I want to find the maximum height of the ball. So you got to remember that when you find maximum height of the ball, you're finding the vertex of the parabola. And I do negative b over 2a. I get negative 30 over 2 times negative 4.9. And when I get x, I get this answer, 3.06 for x. And then I take that 3.06, and to get my y value, I plug that in for t. So you can see up here where I plugged it in. And you get the y. So how you read this is you say, at 3.06 seconds, I am 65.92 meters high. And that's the maximum height, or that's the vertex. This is the vertex. Problem is number 11. How far will an object fall in 3 seconds if it is thrown downward at an initial velocity of 30 meters per second from a height of 200? So my initial height is 200, so I plug that in. It's meters, so I'm doing negative 4.9. I'm using that equation. I'm throwing it down, so my velocity is the negative 30. my velocity is a negative 30. So the question is asking you, how far will an object fall in 3 seconds? So you plug 3 in for the time. Plug 3 in for the time in this equation. At 3 seconds, here's how high it is. Another way to think about the question is, so after the 3 seconds, you take the 200 and subtract 65.9, and you get 134. So this is where it is at 3 seconds. At 3 seconds. This problem is number 12. A ring is dropped from a helicopter at an altitude of 246. How long does it take the ring to reach the ground? So because it's just dropped, velocity is 0. Anytime you drop something. It's only affected by gravity when you drop something. So the initial height, so this is h naught, is 246. So we're trying to figure out when it hits the ground. So at what time does it hit the ground? Well, the time it hit the ground was 3.92. Here's my work for it. Here's a picture. I start out at height. At the y-intercept is like 246. That's how high it is when you start. And at 3.92 is when it hits the ground. It's kind of a picture of what this might look like. This is 13. A coin is tossed upward with an initial velocity of 30 feet per second. So now we're doing feet per second. So now we have to use the other equation that is negative 16 for gravity. So you use your gravity there when you use feet per second. The altitude is 8. What's the maximum height of the coin? So whenever you're doing maximum height, you're just doing vertex, right? So vertex negative b over 2a. You get, this is your x value. How do you get your y? You plug this in and figure it out. And after you solve that, you get 22.1. The question really says, what is the maximum height of the coin? And the maximum height is 22.1 feet. And this is number 16. A potato is launched from the ground with an initial velocity of 15. So if I'm at the ground, your initial height is 0. So that h naught is 0. I'm at the ground. I'm starting at the ground, and I'm launching it up. So 15 is positive. I'm throwing it up. This is positive. What's the maximum height? So there's your equation, but you're just going to do negative b over 2a to get because it's a vertex. I just want to know how high the guy is. How high is it? What's this point, right? What's that point? Anyway, maximum height was 11.48. That's it. Thanks for watching.